My guest today is Dr. Paavo Pylkkänen, who is Senior Lecturer in Theoretical Philosophy at the University of Helsinki. His main research areas are philosophy of mind, philosophy of physics, and their intersection. The central problem in philosophy of mind is how to understand the place of mind, and especially conscious experience in the physical world. Welcome, Paavo.
Thank you.
Yeah, thanks for doing this late in Helsinki. Um, so I want to center our conversation on one of your recent papers, and we'll be going back perhaps some of your book chapters and even before that. So this paper is entitled "Real Consciousness in a Real World: Interactionist Monism." You say here. So in abstract, you say the paper presents and discusses the physicist David Bohm's views on information, meaning, and consciousness, and sketches a new mind-matter view, interactionist dual aspect monism based on them. Okay, so there's a lot there, Pavel. Um, yeah, so um, public has been sort of fascinated by quantum mechanics. So are physicists, I would imagine. Uh, and there hasn't been, I would say, I mean, this is my bias, um, very good explanations for it. So shut up and calculate is not a prescription to understand things. And many worlds, fantasy is not science. And so at the end of the day, you have to have some sort of definition for what's happening. So I'm not a as I mentioned, Paul, I'm not a philosopher or physicist, but I've been sort of attracted to the pilot wave theory that we're going to discuss in more detail. That's because it gives me sort of a little bit of an engineering view how things are happening. So, and that's much more satisfying from my biased perspective. So talk a little bit about. So you say here in introduction, David Bohm and consciousness. So we are going to talk about consciousness and hopefully a little bit about free will and things like that. So you say here in introduction, David Bohm was one of the 20th century physicists whose interests reached beyond physics to try to understand the nature of mind and conscious experience. Professional philosophers of mind and cognitive science scientists may be suspicious of physicists who enter this territory. But there's one thing that is important to remember. The theories of modern physics, based on quantum theory and relativity, imply radically new ideas about our fundamental concepts, such as matter, energy, space, time, causation, information. Yeah, so that's very clear. So um, in physics, there is still a lot of questions. In cognitive science, there are a lot of questions as well. And so we have these two fields they're getting a lot of information, a lot of new ideas, a lot of information, I should say, and they haven't been able to land the plane, so to speak, yet, right? There is so much information, but we still can't really land the aircraft. Um, and so where do you so let's go back, go to David Bohm to start with. So what was he saying?
It, about this relation of quantum mechanics in general, or or more this relation to mind. Which are you more? Where should we start? Huh?
Yeah, so talk about David Bohm and his paper. Was that from like 1960s or something?
Well, he had this 1952 paper was where he presented the pilot wave theory.
Pilot wave theory, yeah. And
Okay.
sometimes called hidden
Yeah,
variables,
that's right.
I
Yeah.
guess.
Yeah.
And as an engineer, I'm quite attracted to that. I mean, I can sort of understand it. uh, and so what's the pilot wave theory?
Okay. So of course, you see, when quantum mechanics was developed in the 1920s, then people were trying to give it this what we call an ontological interpretation, which
Hmm.
saying what exists at what are the objects that exist at the quantum level, and then the dynamics, how do they behave. But then because of the uncertainty principle, we cannot observe the quantum objects in the same way as we can observe the classical object like billiard balls.
Yeah.
So actually, in the end, people like Niels Bohr were saying that we shouldn't try to make models of quantum objects.
Hmm.
And so this was a very radical change for physics, because maybe, traditionally, people felt that physics should tell us about what exists, the nature of reality. And
Reality. Yeah.
so, of course, there were people like Einstein who were not happy with Niels Bohr's view, but Einstein could not come up with an alternative picture. I mean, he had some
Hmm.
ideas. He even tried. He had a paper which he then didn't want even to have published because he realized there was some problem with it. But this kind of started, in the 1920s, 1930s, and so. But then, uh, late 40s, early 1950s, the physicist David Bohm was in Princeton, uh, and he wrote a textbook on quantum theory, which
Hmm.
was what Bohm felt. It was a fairly unusual textbook in the sense that David Bohm really he tried as much as he could provide a physical description of quantum reality while
Hmm.
staying within the so-called Copenhagen or Niels Bohr framework.
Yeah.
And so so what happened was that Einstein read the book, and he asked Bohm to come over to discuss.
Hmm.
And so what Einstein said, that what Bohm had done in his book is probably as good as you can do within the standard view of quantum
Hmm.
mechanics.
Yeah.
But Einstein still wasn't happy. And then Bohm himself
He's
also,
never happy.
well, that's
Einstein
you
is
could
never
say that,
happy.
but he anyway. So what happened there was that maybe Bohm also himself having, this is a book of 626 pages, and it's
Oh,
it's
wow.
it's a
Okay. Yeah.
remarkable study. There's a lot of philosophy in the book, so I mean, I still read it from time to time and find interesting things there. But I think
Yeah.
Bohm himself, he felt also uneasy, and I
Hmm.
think what Bohm also felt that what was missing from quantum mechanics or quantum theory was a kind of description of how the physical state moves transforms over time. So typically, the usual quantum mechanics, uh, you can calculate probabilities for what you will observe,
Yeah.
and then you make your measurement, and you get a certain result, and then you do another calculation,
Hmm.
the probabilities for your next measurement. So somehow what was missing was a more continuous description of what is actually going on, and this
Hmm.
was also bothering David Bohm. And so what happened was that he went and started thinking about the problem, and then he actually came up with a model uh, where not only is the electron a little particle, but there's also a wave or field,
Hmm.
like a pilot wave that is guiding it.
Yeah.
And so he could do that. And actually, Louis de Broglie had presented this kind of model already in 1927 in the
Hmm.
Solvay conference. But the other physicists like Wolfgang Pauli, they
Hmm.
criticized it at the time strongly.
Hmm.
But David Bohm was then able to uh, answered those questions in his 1952
Mm.
paper, and as a result, actually, de Broglie became again kind of he had given up on his modern 1920s, but he again felt felt that he started working on the same approach.
Mm.
So there's kind of interesting history over there. But you see, of course, for David Bohm, uh, he was, of course, waiting that kind of response from the physicist. At least, let's have a debate, or this is,
Right.
he really felt he had discovered something new, and he was pretty much disappointed. I mean, de Broglie was one of maybe the only one of the so-called big physicists who really responded well. And even Einstein didn't like it. I mean, Einstein wrote to Max Born and saying that it's a little bit too cheap the way Bohm does it.
Yeah.
And you see, this is something that Bohm he has mentioned, and also he, when I was discussing with him in the late 80s, early 90s, and he did mention that it was particularly unfortunate at the time that Einstein didn't give support.
Mm.
Because if even Einstein doesn't like, if even Einstein was looking for an alternative view doesn't like it, then why should somebody who is not
Right.
even
Yeah.
dissatisfied with quantum mechanics, so one might ask, well, why, what even actually Max Born said,
Mm.
commented that this was exactly the kind of theory Einstein was looking for. So
Yeah,
Max Born said,
exactly. That's a thought that's going through my mind. This is something that Einstein would have liked because it sort of puts back things into physicalism in some ways, the general theory of relativity. But he didn't like it either, you're saying. Yeah.
well, yes, the thing is that the Bohm theory has this property of non-locality. So
Ah, right.
it could mean something that if you have two particles A and B that either they have a common origin or they have interacted, you take them apart
Yeah.
and you do something to particle A, it's as if particle B is instantaneously affected, which
Yeah.
kind
He
of
didn't like the spooky
it's,
action stuff.
yeah,
Yeah.
that's right.
Yeah.
Spooky
Yeah.
action at the distance, and of course then it raises questions with special relativity. And so now what happens is that actually experiments today are consistent with the predictions of Bohm theory, which are the same as the predictions of standard quantum mechanics.
Mm.
But the model, you can think about it in terms of the Bohm model,
Yeah.
but it's still, of course, at the time. So it would have been kind of interesting to see what Einstein would say today. But there's still a big discussion about
Mm.
this whole issue of no locality, and there's a physicist John Bell who
Mhm.
proposed inequalities that you could then test experimentally, and you see, and this is the way you see even Bohm himself. I mean, he worked like in the 1950s. He worked
Mm.
on this theory, on the pilot wave theory, and then he went to Brazil and worked there.
Mm.
But then he kind of himself lost interest, maybe like late
Mm.
50s, early 60s. And it was only when John Bell came up with his work, but also some research students in London University,
Mm.
people like Chris Dewey and Chris Philippidis and others, when
Mm.
they got interested in the pilot wave theory, then Bohm himself started working on it again.
So let me ask you a loaded question, Paavo. So from African savanna to now, um, our intuitions are developed by basic stuff. Let's avoid the lion. Let's find the water hole to survive. So are we always looking for something that fits to that intuition? In other words, um, quantum mechanics is completely counterintuitive, but then that is quantum mechanics. And so are we trying to sort of fit um, things like quantum mechanics into your intuition? I mean, pilot wave theory, as an engineer, I would say I sort of understand it in some ways. But quantum mechanics, most people don't. And so, is this an attempt to sort of bridge theory with intuition?
Well, you could say that, yeah, fair enough. You could say that because you see, of course, so you see what the Bohm theory or the pilot wave theory does. It postulates that the electron is a little particle and it's moving along trajectories and then it's being guided by this pilot wave. And so,
Hmm.
for example, in the famous two-slit experiment, the particle goes through one of the slits, the wave goes through both slits, and then there's
Yeah.
interference. And then, in that sense, if you like, the particle then knows whether one or two slits are open and behaves accordingly. So there's a
There's a
sense in which
probabilistic outcome. So what you're
well,
observing is
that's right. The
some sort of
outcome is
probabilistic outcome.
probabilistic, but the Bohm from the point of view of the Bohm theory, it's deterministic,
Yeah.
and so in a way it gives a very understandable picture of what is going on. But you see, now the thing is, because of the uncertainty principle, we cannot actually observe the electron moving along a trajectory. So in that
Hmm.
sense, this is a pure hypothesis, which we cannot currently verify, if you like.
Right.
And so then you could say, well, what's the point of it? Well, see, I think Bohm himself felt that this it's anyway what the pilot wheel theory does. It gives a sort of an intuitive picture.
Yeah.
And now it may be that you are correct in what you say, that maybe we're just trying to use our familiar tools
Yeah.
to uh, deal with the phenomenon that is actually something new and strange. But in some sense,
Hmm.
I just see, well, as long as we are aware that this is just a model and it may
Yeah.
or may not be true, I don't see that it does that much damage. That, on the contrary, it's one way of seeing what might be going on. You see, uh, the word theory comes from the Greek theoria, which also could be like a, the way you view something, a way of looking.
Yeah. I mean,
In
it
a
adds to the
particular-
debate. I mean, at the very least, it adds to the debate. And on the other side, a lot of the stuff that we have, wave function collapses when you look at it, or many worlds theory, these are equally unproven ideas. And so it's not like we have, any sort of advantage one way or the other. This, at least, from my perspective, I'm clearly biased about this. It has some sort of mathematical engineering foundation to it. If it is really true, yeah, it sort of makes sense to most technical people. But the other stuff doesn't. I mean, does the cat or the dog looking at the wave function, does it collapse it? Does the saint looking, let the Pope looking at the wave function collapses it? Yeah, I mean, it seems so weird. It has no basis in any of those ideas, I think. Yeah.
Yeah, well, that's correct. That in quantum mechanics there are all these different interpretations, and they each have their maybe in some ways their beauty and elegance, but then you have to pay the price for them. And so the but of course one of see something what the pilot where it does, like let's assume that it works.
Yeah.
What does is that it solves the measurement problem in the sense that there is no collapse of the wave function,
Yeah.
and then you get some of these other, and there's no need for a consciousness to collapse the wave function. I mean, this is something that
Mm.
especially in popular science, it's kind of a fascinating idea
Yeah.
that somehow there has to be consciousness for there to be well-defined reality.
Mm.
And in the same way, perhaps like with the many worlds interpretation, it's maybe the beauty of it is a certain kind of simplicity that you have only the Schrödinger equation and this unitary evolution, and so you don't add things to it, and so I guess but of course in the case of the Bohm theory, the way Bohm himself thought about it later on, because he thought that there's a sense in which the pilot wave encodes information about the environment of the particle, and so it's not pushing and pulling the particle like a water wave would push a floating object. It's more like informing it, a bit like radar waves inform the ship, and of course
It's like an information wave.
that's right. But you
In
see then,
some sense. So it's like
yes,
Wi-Fi.
well,
Um,
yeah, yes, why not? Yeah. But you see the of course then what happens is that then you have to assume that the electron has some complexity so that it can somehow respond to this information, and that of course leads you to discuss. It becomes kind of speculative, but it's not it's not impossible, but it some people might feel, well, that's a price to pay.
I saw a paper. So we're going to go talk about this power, so consciousness. I saw a paper. I mean, I don't have all the details of it, but it was arguing that so we think about the brain as sort of neurons communicating with each other and firing and all of that. Um, but there could be some sort of a Wi-Fi mechanism in the brain, which is sort of instructing, you know, uh, how the neurons should fire. We have no evidence for it. It's pure speculation. But in very complex systems, I don't know, 100 billion neurons and a trillion neuronal connections, um, there could be some mechanism that basically says, oh, it's okay, let's go this way or that way. Um, it is like Wi-Fi, yeah, in some way. So my naive understanding of pilot wave theory is that it is not a particle or a wave. It is a particle and a wave. The particle has energy, and the wave has information to advance it. It seems very elegant to me. I know nothing about this power. So where are we on that? I understand that the physicist community don't like the pilot wave theory or hidden variable theory. So yeah, where is the community now?
Well, I think now I think there are kind of also like different versions of the pilot wave theory, and there's actually a group of like quantum chemists and physicists who really feel that it is very helpful, and they call this like applied Bohmian mechanics. That's a
Hmm.
term that's been used. So there is actually an increasing number of physicists who find the model very useful and even practically useful,
Yeah.
and they apply that in many contexts. But you see, but of course, you see, I'm a philosopher, so I'm not a physicist, and so the reason why I find the pilot wave theory because the way David Bohm himself interpreted it late by emphasizing the aspect that we have something like information that operates at this fundamental level.
Yeah.
And you see Bohm also felt that this might even help us to understand problems beyond physics. So
Hmm.
you see, maybe like in living systems, if you think of kind of organized unity that they have, this might be related to this what Bohm called active information at quantum level,
Hmm.
because this is particularly strong in for the many body systems, like and
Yeah.
things like superconductivity, where you see very organized behavior of large number of
Hmm.
particles. But also you see when we come to discuss things like mind, mental states,
Yeah.
in there it seems again that these are informational states. So my thoughts carry information.
Hmm.
They seem to be able, I can, if I want, I can move my hand. My thought move. In that sense, my thinking, my thoughts move matter.
Yeah.
And there's of course a very nice analogy between in the same way as the information in the pilot wave
Hmm.
can move material particles,
Hmm.
thoughts, associated with my brain can move my body. And I think people who look at the pilot wave theory a little bit
Hmm.
deeper and listen to Bohm's ideas about information, I think many of them are very struck
Yeah.
just that at least there's an analogy. And well, it doesn't mean that it doesn't prove that there's anything quantum mechanical going on in the brain. I mean, that's another,
Yeah.
that's a more difficult question, but it perhaps is something sort of worth exploring.
I mean, so from a naive perspective, Power, so I'm quite attracted to this idea that, I mean, it's sort of combining physicalism, things moving around, with something beyond that. In the pilot wave theory, it is sort of a field that's guiding the particle. And now, I mean, we have this whole other world that we don't understand at all, cognitive science, neuroscience, and we've been seeking some way to sort of explain, for instance, consciousness, and there hasn't been any advances. I mean, we've been looking for many decades. There has been so there's some sort of a connection between physicalism, as you say, if I want to move my hand, I can do it, and something beyond physicalism, which is, something else going on there. And the brain is a very complex instrument. So I would be very surprised if let's say the pilot wave theory is true. I'll be very surprised if the brain is, not making use of it, because that seems quite elegant. So yeah, talk a little bit about consciousness. Yeah.
Well, you see, this is this is the it really is the question of uh, in philosophy of mind, which is an area where I have been working. So uh, we think of mind as a more general category. So we
Hmm.
have we have all kinds of mental states. We have thoughts and feelings, emotions. Now these may or may not be conscious. Okay,
Yeah.
so in that sense, we say that mind, mental phenomena, is a broader category than conscious phenomena. So conscious phenomena is a subset of mental phenomena,
Yeah.
and so that's one important thing. So you see, we might you see in the it might be easier to use the pilot wave theory to discuss uh, mental phenomena.
Yeah.
But then, it's an additional question. Well, what is it that makes a given thought conscious thought? What happens? And this is something, of course, that's called this hard problem of consciousness in philosophy, which is basically that, a lot of people believe that brains, neurophysiological processes give rise to conscious experiences. But
Hmm.
then you see, it seems that we have no idea how that happens. I mean, we don't really have a good theory of how these, if you like, objective physical processes could give rise to something like our subjective
Yeah.
conscious experience of, let's say, including phenomenal properties like the color orange or red we
Hmm.
are seeing right now. So, but anyway, but you see, so now, how could the pilot wave theory help here? Well, you see, what it does is that it suggests that the fundamental level of physics is it's not just particles and fields that interact in a mechanical fashion, what Bohm postulated is that there also exists this, it is a kind of field because you use a wave function to describe it, but Bohm emphasized it's much more subtle. It's not an ordinary physical field that carries energy and momentum.
Yeah.
It's more the idea of information and what he called activity of form. And he would claim that this is like a mind-like quality. So we have something primitive mind-like already at the level of fundamental physics.
Yeah.
And in that sense, we're changing our picture of the physical world, really. And you see, then of course, then you might say that the question then is whether, if you like, information in our mind, the way our mind works, and the way information works with human beings, is in some ways analogous to this quantum level information, or even strongly similar to it, in the sense that, so for example, Bohm himself thought that not only is there this pilot wave guiding the particles, but they could be like a second order or super pilot wave that would organize the first order, and a whole hierarchy of this, and somehow mental phenomena could come in at the higher level, this
Yeah.
hierarchy, so that way you would try to relate what we call mind to what we call matter.
Yeah. So the insight here, Paavo, if I understand this, is that it's an information wave. It is not carrying forces. It's not carrying momentum. It's not carrying energy. It's carrying information. And a bit like Wi-Fi, let me go back to that analogy. I don't know if it's the right analogy, which means that we have to combine physics with information, or physicality with information. Um, and that's the part that we have been missing. So this is in some sense, this is potentially what's happening in the brain. So if we dig deeper into all the hardware stuff and say, let me figure out how the electrons are moving, where all the neurons are firing, back propagation, artificial intelligence. I clearly have a bias around this. We're not going to find it because there is something else beyond that that makes the brain work. And that is not physical. It is actually an energy, or sorry, it's not even energy, it's an information field. And so you can really measure it in some way.
Well, you see, I think
Yeah.
this is an important point, because you see, I think Bohm himself thought, and I also think it's reasonable to say that there's a small energy that's carrying this information, because otherwise we would end up with dualism, like saying that we have something completely
Yeah.
non-physical affecting the physical, and this is going back to the Cartesian dualism. So I think it's important to say that, at least to assume at this point, that this, let's say that the information in the pilot wave,
Yeah.
there's an energy that is containing or carrying this information, which we haven't been able to measure yet.
Okay.
And so in that sense, but it's still an interesting idea that it's if the essence of this thing is information, then, for example, it may not be primarily a spatial thing, because this is one of the, you see, there's a related notion. There's something Bohm, he developed another theory he called the implicate order, which is sort of emphasizing that the implicate order is contrasted with what he called the explicate order, which is the usual, our usual everyday notion of matter in space and time. So these are objects that are outside of each other and things that we can touch and manipulate and all that. But then the idea is that actually this so-called manifest explicate order is unfolding from this underlying implicate order, and this is in a way similar to, inspired by quantum field theory, where actually particles can be created and annihilated.
Yeah.
And so Bohm himself, he assumed that the matter is constantly being unfolded and then enfolding. There's this
Mm.
constant process, which is recurrent in the sense that then if I look at this object, it looks as if it's just there.
Mm.
But Bohm is assuming that there's this underlying very rapid movement of
Mm.
quantum fields that is actually sustaining it. But of course, at this level of this implicate order, then space is no longer the fundamental connection. It's not the only connection. We always, of course, used in physics, we are used to thinking of
Mm.
space as being the way of relating objects, and then, of course, the laws of physics
Mm.
are such that they, forces tend to diminish as the distance increases. But of course, you see already at quantum mechanics, if there is this non-locality phenomenon,
Yeah.
as a lot of people think there is, then that suggested that the space doesn't make a difference because these two particles that are connected, the other one could be in other far away,
Yeah.
the edge of the galaxy, and these correlations would still be there. So there's this
Yeah.
whole notion, and you see now in philosophy, in a way, this goes back to the philosopher René Descartes, who kind of suggested that what is characteristic of consciousness is that it doesn't take space. If you like,
Mhm.
conscious experience
Yeah.
doesn't it doesn't take space, although it is associated with the brain. Whereas
Mm.
matter, Descartes defined as something that extended substance, something that actually, you
Mm.
know, Descartes defined it matter in strongly spatial terms. And I think that this Bohm's idea of both this idea of the pilot wave carrying information and the more general idea of implicate order actually fits very well with this Descartes idea of mind as something that is not extended.
Yeah.
At some sense, you see, it's there. And although, of course, in conscious experience, we also experience an
Mm.
extended world. Like when you're dreaming, you may find yourself in a virtual world, if you like.
Mm.
It's not.
So there's sort of a correct me if I'm wrong, Power. Um, so we got onto this particle wave duality early on. You said we made observations and it doesn't fit with particle or wave, and we went on a tangent in some ways to try to fit it with a theory. Um, but it might be that it's particle and wave simultaneously. Um, and it's not that the particle is carrying the wave, and that's what some of physical science we've been looking for. It's not that the particle is carrying the wave, but the particle is guided by information wave. And so it's not a particle wave duality the way that physicists think about it. It is actually a particle wave duality in the sense that two different things working together simultaneously. Um, and so if you were to test this, how could we sort of conclusively prove this is the case for pilot wave and those theories?
Oh, that's very interesting question. Of course, one thing would be that if you could use the pilot wave theory to predict uh, results that are different from the standard quantum mechanics, and then
Mm.
if you could then falsify the usual quantum theory. Of course, Bohm was hoping for. I mean, he was discussing that already in his 1952 paper. So he was suggesting that maybe, like at very large energies,
Mm.
something like that could happen, but it's not clear. But you see, the other thing is, of course, that what kinds of experiments we could do to detect the pilot wave. I mean, there are some suggestions. You see, there are some suggestions in physics that you might be actually able to observe the so-called what people call the wave function, or this what is described
Mm.
the entity
Because it
described.
carries some very, very small energy,
Well,
maybe. Yeah.
I don't remember if they are really there talking so much about energy. There are various whether it would connect to what is known as weak values, and
Mm.
it's a work by Lundin and others. But I guess for the pilot wave theory is also that if there was some way, supposing the pilot wave is there is this small energy that is carrying the information, then if
Mm.
there was a way of somehow measuring that energy, then that would be a step toward it, but or
Mm.
detecting it. But of course, I think you would need a physicist to really think in more concretely how that possibly could be done. I
How
think
to set up an
Bowman
experiment?
highly,
Yeah.
yeah, Bowman highly mentioned that, but I don't know if they really had concrete ideas of how to explore it.
So one thing I couldn't understand, Power. I mean, not that I understand anything. The the non-locality and entanglement. How does the pilot wave theory explain those things? I mean, I felt like as an engineer, I could sort of understand exactly what's going on, but then we have non-locality and we have entanglement. So, how does the pilot wave theory gets to that?
Well, you see, the pilot wave theory, the way Bohm himself liked to formulate it, there was this notion that the pilot wave gives rise to a quantum potential.
Oh,
It's kind of quantum potential energy, and it's this energy that then mediates the influences. But then it's so fragile that you cannot modulate it, so you cannot send signals with the help of this quantum potential. And then in that sense, you're still being consistent with relativity.
mm,
But of course, then people feel that there is still a tension between the pilot wave theory and relativity, because these non-local influences
mm.
happen in a there's like a preferred frame that the Bohm theory assumes, and the relativity doesn't have that.
So if you assume, I don't think I understand this correctly, but if you assume that the information field is universal and every particle moving in and out is sort of using that information field, then it's very easy to have non-locality. I mean, they are all sharing something universal. Is that the way to think about it,
Oh,
or
no, that's actually a very curious feature with this pilot wave, is
yeah,
that, see, now you could have situations like I mentioned when you have a many-body system, like in superconductivity. Then what you're saying is that there is this common pool of information,
yeah,
and all the particles are responding it. It's a bit like if you have a ballet dance where you have many dancers and they are all responding to the same script,
yeah,
and in a coordinated way. But then you see, like in the case of superconductivity, when the temperature goes up, then you say that this wave function, or if you like the pilot wave, the wave function factorizes, and
mm,
now it can be that each particle will have its own pool of information,
mm,
and this is very interesting because so there's a sense in which it's a private a particle can have its own private information,
mm,
and you can even have situations where you could have two particles. Let's say if you have a neutron and some other uh, uh, particle,
yeah,
and they are so that, for example, that this particle could be under the pilot wave of the other one. This one would
mm,
not feel it. So this is very interesting. It's a
mm,
different from the way we usually think of these fields. Like gravity would be the universal that everything that has mass would then experience that. But with the pilot wave theory, there is this privacy, and actually in the philosophy
mm,
of mind, we think that, because you see one of the big questions in philosophy of mind is privacy of our experience. That there's a sense in which my experiences are private to me and yours to you, and somehow this whole idea that even in the Bohm model, even a single electron could have its own private information. It's kind of another interesting analogy.
So there's locality in that sense.
Yes, in that sense, yes. That this non-local connection can break, and actually they are very fragile. And so this is why, for example, a lot of people would think that in the brain it's too warm, wet, and noisy, so that you would have any like this kind of entanglement. Others say, well, maybe biology has solved the problem, that there are
Yeah, so just like Bell theorem, we could actually test this, right? So if I understand you correctly, Paavo, you're saying there's clearly no locality. I mean, we can sort of observe it in entanglement, but there could also be local effects that we can also measure potentially. I don't know how you measure it. And if we can prove, unlike Bell's non-locality proof, maybe there is a proof for localization and non-locality simultaneously in some ways. Is that possible?
Well, you see, I'm not that much of an expert on those issues, but I know, you see, there are still some people who question even the non-locality, and then they will, and then there are a lot of disagreement how we should understand the non-locality. So that's a sort of an area where philosophers of physics are still discussing, and there's a variety of possibilities.
It's an
But I
open
think
area, yeah.
it's the mainstream. I mean, it still seems to be like pretty much the received, maybe it's like, I don't know if it's safe to say, but it's a majority view that there is some kind of non-locality in quantum mechanics.
So you say here in your paper, interaction is dual aspect monism. You say here, can we have a monism where there is room for both mental and physical aspects? And can we have a two-way traffic between these aspects? So this is sort of the crux of the problem, right? Some call the hard problem. Uh, can we have a two-way communication between mental and physical aspects? I think physical aspects, we've been sort of getting to it. The mental aspects is still very, very unclear. So can we sort of connect them together?
Well, you see, this is of course the big question in philosophy of mind, and you see, well, there's one tendency has been to uh, try to reduce mental states to either neurophysiological processes or perhaps some kind of computation. But you see, then people feel, well, you are not explaining consciousness, you are just explaining it away. That
Yes.
that because then it would seem also that the mental phenomena seem real, and it seems that they are also able to influence physical processes. So you see, what things mean to me can have a very powerful physical effect. If like if I walk in the dark night and I see something suspicious and I interpret it as danger, it means danger to me. Then it really is a very powerful thing. But it's the meaning that makes a difference. And so this is something that philosophy has difficulties, because modern philosophy often emphasizes the physical. It's kind of a materialist underlying paradigm, and so somehow we don't seem to have a ways of allowing that things like meaning or even phenomenal properties like consciousness could actually genuinely influence the physical domain. And this is why I think the Bohm's work and also the pilot wave theory is important, because because Bohm is introducing this information and meaning all the way into
Mm,
physics. And in that sense, opening up the possibility that there could be what we call genuine mental causation, so that our mental
mm,
states, by virtue of their mental properties, could also have an impact. Because this is, of course,
mm.
the way it feels, that it's what things mean to you that makes the difference.
Um, so I will touch on this power. So active information as a bridge over troubled philosophical waters, you say here. So 1990 article to which we referred above, Bohm tried to understand the relation of mind and matter in this pilot wave framework. It is typical of mental processes that can make a meta mental step. We can think about objects, but we can also think about our thinking and so on. It demonstrates that we demonstrates that there exist extended hierarchical organized levels of information in the human mind. Yeah, that makes sort of intuitive sense to me. So um, if there's a hierarchy in the mind, I suspect there's a hierarchy. I have no evidence for it. Um, so if we go to the lower branch of that, let's call it decision tree. It's not the right analogy. We go to the lower branch of that, and we can do all sorts of science experiment, mathematical calculations. We're going to miss the big picture. And I would argue this is what's happening in AI, and this is what's happening in cognitive science. The sense that, we we like the hardware things, we can go into the hardware and try to understand it. But it's not the hardware that is doing it. That's a problem, right? What do you think?
Well, yeah, I mean, you could say that in if you think about intelligence, that this is the way Bohm was thinking about it, is that you can always, like, you may be at the given, you're maybe thinking about something, uh, and but then you can also make the meta level step and start thinking of, you can have a higher level of thought
Yeah,
or higher level of information, which is, and from there you might perceive the lower level, and
yeah.
perhaps you might even bring some order, and you might even have like an insight in this when you're having these perceptions. And so Bohm was claiming that intelligence is based on the possibility to always transcend the level where you are. And,
Hmm.
and we humans seem to have that. I mean, we are not necessarily always using it, but potentially we seem to have that. And now this could be related to Roger Penrose had the idea that intelligence is not algorithmic in the sense that we have
Hmm.
some of these abilities. And of course, it is possible that this is still missing in AI, that
Hmm.
when, I guess the danger in AI is that we are, we already, we like to believe in that we have the right tools. So somehow we just, and amazing things being done. I'm
Yeah.
very amazed by the large language models and all that. But then again, is there, is there genuine intelligence there? And then is there the kind of intelligence that humans have? And
Hmm.
my feeling is that no, that we could still, uh, it could be still that these notions like this active information could be relevant here.
Yeah.
And at least, you see, this is still something that is arising from physics. So it's not like completely out of Bohm's imagination. It's actually a way of looking at, our best theory, quantum mechanics,
Yeah.
in a certain way, where you can see that maybe there is, the wave function operates as an information,
Hmm.
and this could be the general principle. Maybe the brain is doing something like that, but at another level.
Hmm.
And our so to really to understand the mind, the brain, and possibly intelligence, maybe we also could look at some of these ideas.
Hmm. Yeah. So for me, power quantum mechanics is like a Pandora's box. When you open it, you find so many interesting and potentially bad things in it. And we have had it for about 100 years now. Still haven't figured out what's going on, which is fine. I mean, sometimes it takes a long time. Um, but it sort of opens up. Quantum mechanics is a tool to open up your mind. It tells you you remain ignorant, uh, in spite of all the stuff you're trying to do. You still don't know. You still don't know it, right? So, yeah, I mean, it's actually a force to improve humanity in some ways. So you have a chapter here, the action perception cycle, the two-way traffic. So you say here we can now also consider how action can be understood in this framework. Action being a topic in which contemporary philosophers are very interested. The idea is that from each level of somatic unfoldment of meaning, there's a further movement leading to activity on a yet more manifestly somatic level. Um, yeah, so this part I don't quite understand, Power. So can you explain that?
Well, maybe it's a little bit like a complicated Bohmian jargon there, but basically, it's just the idea is that uh, meanings when you experience the meaning of something, that's
Yeah,
presumably happens at the fairly high level in the hierarchy. But
yeah.
once you understand the meaning, then it will unfold into activity, and in the end it will
Mm,
make you do something. So this is something the Bohm called the signa-somatic relation, or signa-somatic activity, where signa
mm.
is significance and soma is the body. So it's a bit like psychosomatic, but he liked the word signa-somatic better.
Mm.
And but you see, in perception, in perception, I'm taking in information, and at some stage then I will understand its meaning. So this goes in a cycle. So in perception, I take in information, I understand what it means, and then what it means typically determines how I act.
Mm.
And so that's the two-way traffic from the manifest physical to the more subtle mental levels, and back. And this is so there's
Yeah.
this energy where there's constantly a two-way traffic between the two.
It's like a cycle. So I'm thinking back to AI, Power. So we have this prompt engineers prompting AI, um, and it produces something, and the engineers say, "Let me prompt you to produce a better outcome." In some sense, it's a bit like that, is it?
Well, yes. I mean, yes, you could, but of course, it's our perception. It's
Yeah.
like you open your eyes and you perceive. So in a way, you're getting the input. I mean, this is, in some ways, this is a very standard notion in cognitive science, but I think Bohm is giving it a slightly new way of looking at it.
Hmm. So you say here, what sense does mind exist for Bohm? He says it's now also possible to consider in what sense that which we usually refer to as mind exists for Bohm. He says that you are you it's he says that as you act according to your intention and as a perception comes in, there can arise an indefinite extension of inward signosomatic and soma significant activity. Um, can I think about this as reflection in
Yeah,
some
yeah. I
ways?
mean,
Yeah,
it's
yeah,
again trying to just it's something very familiar, but it's trying to describe it in this framework, what he calls this soma significance, which is actually yet another.
yeah.
It's a notion related to the active information, but so it's really trying to say that there are. You see, when you're reflecting, so
Hmm.
there's a sense in which your thinking is decoupled from physical action. So, for example, suppose you're reading a map,
Yeah.
and you are many possible routes there. So it's of course it depends. If you are in a if you are on a holiday, you might take the scenic route. If you are in a hurry to go to the station, you take the quick route. But
Mm.
there is a period in your deliberation where you might have all kinds of simulations, virtual, what Bohm calls virtually active information, and
Yeah.
this is, if you like, decoupled from the executive centers in your motor cortex, which is the actualization of these possibilities.
Mm.
So the so that's the idea there, is that what we call mind is still this activity of information, which does involve, it has this physical aspect,
Mm.
but uh, but it's still not actually active information. It's only like potentially or virtually active.
Yeah, so let's finish up with it's very late there in Finland. Let's finish up with consciousness and free will.
Right.
So let's talk about more generally. What I think what you're trying to do, Power, correct me if I'm wrong, is to put a physics basis to mind, to consciousness, and problems related to that, like free will, for instance. Um, and we haven't been able to really get down to it from a cognitive science, neuroscience perspective. But here might be an approach to get to it from physics perspective, which would be very, very interesting. And so based on all your research, where do we stand on this? So is consciousness a physics explainable thing?
Well, I think it's importantly is that we're not trying to reduce consciousness to the quantum level. That quantum level is just one stage. It's like the missing link. But
Yes.
then what we call the mind could involve these high order, like the higher levels in the hierarchy. But it's still but it is physics inspired up to a point. And you see,
Mm.
that's important because physics and neuroscience is usually used to in some ways deny things like free will or consciousness or anything. Why? Well, because there's no room for them in physics. And I think what people like David Bohm was trying to show is that physics actually has room for these things. And this is
Mm.
partly why this notion, that if this notion of information is fundamental in physics, it operates there in a certain way. Information in our mental states is something much more subtle and complex. Okay, but and free will comes in at that level, maybe in some
Mm.
very it can be a very fine response to what things mean to us, where we are
Yeah.
have at least some freedom to consider the alternatives. But the
Mm.
fact that this uh, information can then connect to the information at the physics is makes it possible for, in some ways, for the free will to be free because of
Mm.
the higher levels, but also to influence the more fundamental dynamics because that fundamental level is open to informational influences. So I think in this sense it is a kind of it's a view which on the one hand wants to have physics there. So it's
Mm.
saying that physics is important, but it's also saying that physics has changed in such a way as to make room for
Yeah.
things like free will and consciousness in a way which we do not have in like classical physics or classical neuroscience.
Yeah. Yeah. I can see that. So I just want to summarize your paper here. So you say here, to summarize, one advantage of the Bohmian approach is a notion of objective and active information. Active information, we didn't use that term that often. Active information is extended to the quantum level. There exists a primitive mind like pole even at the quantum level. So we do not ask, how can a purely physical system, brain, give rise to conscious experience? We ask, how can a system where each level has a physical and a mental, informational, you say here, aspect give to the conscious experience? this latter question may be easier to answer, thus alleviating the hardness of the of the hard problem. Um, yeah, I'm very, very attracted to this information wave thing, Power. I have to think more about it. It makes it makes intuitive sense. So, as a Homo sapien, uh, maybe when things make intuitive sense to me, to my classical brain, I'm just gravitating toward things, that sorts of make sense, but it may not be true, right? And so for me, it makes sense. It doesn't mean anything, actually, right, in the grand scheme of things. So what do you think?
Yeah, sure. I mean, this is the this is the basic hope here is that whether we could have some sort of understanding of this whole picture, and whether these ideas from information would help us there. So fair enough.
Excellent. Yeah. Thanks so much for spending time with me, Pavel,
Thank
this
you.
late in Helsinki.
Thank
I
you.
hope to get there before I check out at some
All
point.
right.
I've never been there.
Excellent. Yeah, we're coming. Yeah, well, all right. Well,
Nice seeing you. Thank
bye
you.
bye.